Welcome to ClickMyProject.com. Our project title is Implementation of the Deep Learning Technique for the Identification of the Yoga Poses. And this is our abstract. Many individuals all around the world now do yoga as a regular part of their lives. Because of this, yoga posters require scientific examination. Pose recognition algorithms have been shown to be useful for the both identification poses and helping people practice yoga more precisely. Recognition of the poster is a challenging task due to the lack of availability of the dataset. Also, to detect poster on real-time basis, 20% of dataset was utilized for the eye testing, and while the remaining 80% for the training. This dataset is examined using the deep learning technique for the classification and achieves accuracy of 85%, and then finally we classify the poses accurately. This is the objective. Develop a yoga classifier, improve accuracy of classification, improve the prediction of yoga poses. This is a system architecture. The first module is the data selection. Here we use the image data set. So first we select the data and pre-process the data by using label encoding. Label encoding is used for the conversion of the string to the integer values, and then data splitting is you have to split the data into two categories. One is the training and testing, 80% of the training and 20% of the testing. And then classification, here we use the deep learning classifier CNN, and then prediction, and then performance analysis. This is a flow diagram. First is we select the data and pre-process the data by using the missing values and the label encoder. And data splitting, here we split the data into 80% data and the 20% of testing. Classification, CNN, deep learning classifier, and then prediction. In performance analysis we have to calculate the accuracy and loss. And this is a use case diagram. From the user point of view, what the process is done, we explain in this diagram. First data selection, then data pre-processing, then data splitting, and then classification, and then prediction, and then performance analysis. These are done in the system. And this is the ER architecture. When we start the program and load the data set and select the data and pre-process it, split the data, classify it, and predict what the pose of the yoga what we given in this, and then get the performance analysis. And this is a sequence diagram. Start the program and select dataset, load dataset, and data selection, and then data pre-processing. Here label encoding and the missing zero values, and then model selection, and then classification. Here we use the CNN, and data splitting, performance analysis. Finally we have to predict what the poses. First execute the program. After execution we got the plot for each label in our data set, counting with the label. And next, this is a pie chart, and this is for the proportion of each category in the trained data set, and this is a test data set. And here we initialize the model as sequential, and then convolutional 2D layer, max Boolean layer, batch normalization. These three are the first layer, and then these three are the next second layer. This is the third layer, and this is a dropout layer, convolutional 2D, and then max Boolean 2D, and then batch normalization. All the layers are fitted properly. Finally we got the total parameters as this one, and then trainable as this one, non-trainable as this one, and then we ran our epochies. We got our epochies as 30. one by one. After execution, we will find the loss and accuracy. The loss is decreasing as 0.00149 and accuracy we got is 0.9981. This is a loss graph and this is a accuracy graph, and here is the our accuracy score, and this is the original label of the this image, and then this is a predicted image. And after select some image, we predict like this.